The European Astro Pi Challenge is an ESA education project run in collaboration with the Raspberry Pi Foundation. In Mission Space Lab, your first challenge is to design and program an experiment to be run on an Astro Pi located in the Columbus module on the International Space Station. In this video, we're going to give you an overview of how to come up with a great idea, as well as some details of the Astro Pi that can help you do that. Let's get started. To begin, let's see where our two Astro Pis, called Ed and Izzy, are located inside the ISS. Ed, which runs experiments for life in space, is situated about here in the Columbus module of the ISS. Izzy, which runs the Life on Earth experiments, is placed in a window looking down at Earth and has an infrared camera, but more about that in a moment. So how do you get started coming up with a great idea? It can seem like a daunting task, but don't worry, you've got this. The trick is to break the project down into pieces and to start small. For example, when someone wants to build a house, they're going to break the project down into steps. Maybe first deciding what type of house to build, and then drawing up plans for what it should look like and how to build it, before finally gathering the materials and then doing the building work. You can start defining your experiment idea using the same kind of strategy. First of all, every scientific investigation has a purpose. You need to define what sorts of questions your experiment will try to answer. Do you want to explore life in space, or learn about life back on Earth? Start by familiarizing yourself with the different sensors in the Astro Pi computers and write down what they could help you find out. Next, think big. Don't worry about whether the ideas are good or even realistic at this stage. Just write down as many ideas as you can, and then start to refine your ideas by discounting those that don't fulfill our recommendations in this video. Once you've decided on your idea, come up with 3 possible ways of finding out the answers to your questions in an experiment using the Astro Pi sensors available to you. Now I'm going to go over a few common mistakes that teens make when designing their experiment. The first is about the type of camera Izzy has. You might remember I said it's an infrared camera. On the electromagnetic spectrum, infrared is usually divided into bands: near, short, mid, long, and very long. A thermal imaging camera typically operates in the long infrared band, converting infrared into the typical heat image that you might be thinking of. The infrared camera on Izzy, however, cannot do that. Izzy's infrared camera detects visible light and near-infrared light, which is part of the electromagnetic spectrum close to visible light. We use a filter that blocks the red and green light, but lets the blue and near-infrared light through. Since the camera detects some visible light, when you get your photos back from the ISS, you can analyze plant life using the Normalized Differential Vegetation Index, or NDVI. Here's an example of an analyzed photo. The other thing to know about Izzy's camera is that it doesn't take good pictures at night. These pictures are completely black. So experiments that try to capture light pollution or any other nighttime activity unfortunately won't work. Unlike Izzy, Ed has a visible camera, but it's important to remember that you can only use Ed's visible camera as a light sensor, meaning you can't store photos or record any video that you capture. This is to make sure we respect the privacy of the astronauts on board. Now, we also recommend that you don't try to capture specific locations on Earth during the 3 hours when your code will be running. We won't be able to tell you what the ISS is passing over in advance, so photographing specific ground locations is extremely unlikely. Remember as well that the ISS flies over locations between 51.6 degrees north and south of the equator, as this video shows. This means it never flies over many parts of Canada or parts of Northern Europe, so watch out. For all experiments, we have these additional recommendations. Real-time communication with the Astro Pis is not possible, as we don't have a radio communication module to be able to give instructions from Earth to the Astro Pi computers on the ISS. Also, as tempting as it may be, your idea shouldn't be a game, but a scientific experiment. Finally, your experiment can't rely on astronaut interaction. We can't be sure when an astronaut will be around the Astro Pi computers, and they have their own busy working schedule. Here's a reminder of our recommendations. not be able to accept experiment ideas that don't follow our recommendations. Best of luck coming up with ideas, and have fun.